Steam-Assisted Gravity Drainage, ChE0100 Design Project.
Hello, my name is Jiries, and today we would like to present to you why steam-assisted gravity drainage is the most effective method for unconventional oil recovery. The first thing I would like to clarify is that conventional and unconventional oil do not refer to different types of petroleum, but rather different methods of how the oil is extracted. Conventional oil is obtained by drilling below the surface of the earth into known petroleum deposits. The oil is collected using either natural pressure of the reservoir or through a pumping action. On the other hand, unconventional sources of oil do not flow near the surface and require extraction techniques beyond the classical methods using drilling and wells. For example, oil sands, which are referred to as unconventional, lie more than 200 feet below the ground and are therefore too deep to be mined. So you may be wondering, why do we even care about unconventional oil if it's so difficult to obtain? The reason is because we need a way to meet the increasing demand of petroleum, and 70% of the world's total oil reserves need unconventional production means to be accessed. The most effective way to access this oil is through steam-assisted gravity drainage, also known as SAGD. This process is an enhanced oil recovery technology for producing heavy crude oil and bitumen. This type of production is most popular in Alberta, Canada because of the Athabasca oil sands, the largest known reservoir of crude bitumen in the world. Typical oil found in the oil sands of Alberta is much thicker and more difficult to flow under normal operating conditions. Conventional methods to extract crude oil are inadequate for this type of petroleum because of its high viscosity and therefore inability to flow through a reservoir. The oil is located so deep below the Earth's surface that its temperature is not affected by changes in surface temperature. The ground temperature remains low enough to create great resistance. Steam-assisted gravity drainage uses in situ drilling, which refers to recovery techniques that apply heat or solvents to the heavy crude oil reservoirs beneath the Earth's crust. It allows the bitumen to be pushed through a cold reservoir without regaining its lost viscosity. Although I'd like to, I cannot take credit for this invention. Dr. Roger Butler, an engineer for Imperial Oil in the 1970s, conceived the gravity drainage idea. Butler developed the concept of using horizontal pairs of wells and injected steam to develop certain deposits of bitumen considered too deep for mining. Butler's innovation allowed the oil sands of Alberta to emerge as a key energy source of the world. Now, Tom is going to explain how steam-assisted gravity drainage actually works.
Thanks, Summer. I will now discuss the methods of steam-assisted gravity drainage. SAGD uses a simple method of two horizontal well bores to reach unconventional oil deposits. The deposit is drilled into two wells, approximately 4 to 6 meters apart. The steam is injected at high pressure to fracture the rock deposits, and reduces the viscosity of the target oil deposit. Once the emulsified mixture of steam and bitumen is at a sufficiently low viscosity, the gravity drainage aspect of the process comes into play. The emulsion is then pumped out of the deposit after having settled into the lower wellbore. This image shows the behind the scenes of SAGD oil recovery. Once the bitumen has been recovered from the formation, it has to be demulsified. This part of the process helps separate the condensed steam and the desired oil product. Without this part of the process, the saline water could cause corrosion issues during the refining process. SAGD also uses some heavy fractions of the recovered oil to produce syngas. Syngas is a gaseous fuel composed primarily of hydrogen, carbon monoxide, and often carbon dioxide. This syngas is then used to heat the recycled water into steam again. The newly generated steam is then injected back into the deposit again to fuel the extraction. SAGD used to consume about 70 million cubic meters of water a year, but in recent times this has been reduced to 18 million cubic meters. Also, SAGD has reduced the portion of freshwater uses by approximately 60% instead of using non-potable saline groundwater. SAGD has become much more efficient and thus effective since its inception. It's a process that is necessary for recovering unconventional oil deposits, yet despite that it has been continuously made better and more viable for today's intensely competitive oil industry. Now Blake will tell us about his analysis of steam-assisted gravity drainage.
Now that we know how SAGD works, let's explore the current state of the process in the modern oil industry. Recent SAGD operations on the Athabasca sands have achieved steam-to-oil ratios, or SORs, of less than 2.5. Steam-to-oil ratio is an important statistic used in evaluating the efficiency of an oil extraction process. It is the ratio of the number of barrels of water required to produce 1 barrel of oil. A lower SOR is desirable because it means that less water was used in the process. This translates to less heat being needed to turn that water into steam. Overall, a lower SOR means that a process is more efficient in terms of water used and fuel spent. Another important statistic in SAGD operations on the Athabasca sands is the bitumen recovery rate. SAGD operations on the Athabasca sands have produced bitumen recovery percentages of over 50%, which far exceeds any other in situ operation in Canada. SAGD can also be analyzed through oil price trends. This graph shows the prices of 3 types of crude oil from 2012 to the present. WTI and Brent are 2 high-quality blends that are used as benchmarks for pricing other blends. These benchmarks are produced via conventional methods and are extracted from shallow shale fields. WCS represents the heavy crude produced through unconventional methods, namely SAGD. The blue highlighted region shows the price trends since 2014, and it can be seen that WCS, which is consistently cheaper, makes gains on the benchmark blends. In the beginning of 2014, WCS was sold nearly $35 cheaper per barrel than WTI and Brent. Now, the gap is just $10. This represents a strengthening of WCS relative to conventional oil. The increasing price of WCS is due to the increased use of heavy crude by the U.S. refineries. With SAGD production rates hitting all-time highs in October, the rising cost of WCS is attributed in greater demand for heavy crude. The trends show an increasing reliance on heavy unconventional crude produced through SAGD. This trend is expected to continue as shallow conventional oil is depleted. SAGD, as an unconventional method, is generally thought to be more expensive than other conventional methods. This is because the oil is harder to reach and requires more complex engineering. However, this graph shows that SAGD has the 4th lowest break-even cost. The yellow highlighted region shows the break-even cost of in situ bitumen, or oil produced by SAGD, in comparison with other blends.
Thank you, Blake. To summarize, SAGD was proposed by Dr. Roger Butler. He was tasked to find a way to efficiently harness crude bitumen far beneath the surface of the earth. This required the invention of new unconventional methods able to access more complex oil reserves. As previously mentioned, the largest known reservoir of crude bitumen is the Athabasca oil sands in Alberta, Canada. This reservoir contains approximately 135 billion barrels of oil. However, this reserve cannot be mined using conventional methods because of its depth. The depth of the crude does not allow heat transfer from the surface, therefore the crude is more viscous and cannot be cost-effectively extracted. In the 1970s, Dr. Butler introduced the idea of steam-assisted gravity drainage to solve this problem. This unconventional method utilizes 2 horizontal wells, high-pressure steam, and gravity to thin the oil and allow flow. SAGD is projected to be capable of retrieving 90% more oil from the Athabasca oil sands than conventional methods. SAGD is the most highly used method at Athabasca. The method is very efficient. The fuel cycle break-even cost of SAGD is 4th lowest overall. Not only is it a cost-effective method, it also uses less water than many other thermal extractions. SAGD uses as low amount of water as 2 barrels per every barrel of heavy crude produced. Production of crude oil using this method is projected to continue to increase. While steam-assisted gravity drainage is not a perfect means of oil recovery, it is among the best unconventional method available for use in locations similar to Athabasca oil sands. Unconventional methods are the way of the future, allowing cheaper extractions from new, challenging locations.